Hey, welcome back. So this section is on two new data structures that fortunately are much lighter weight, much simpler to discuss compared to the ones we've seen like lists and dictionaries. We spent 15 or so videos just talking about lists. Well, this section is going to cover two data structures and it's only going to be 3 to 4 videos tops. So let's get started. And the first thing I'll do is just quickly highlight our objectives. So these are two new structures, and first we want to just be able to describe what they are, how they compare to things like lists and dictionaries, and then create and access them. We want to learn about the built-in methods, just like we did with lists and dictionaries. Fortunately, there are way fewer. And then we want to iterate over sets using loops and set comprehensions, and we'll also compare and contrast sets and tuples with lists and dictionaries. So let's get started by talking about tuples. What the heck is a tuple? Also, some people say tuple. I hear both, but I definitely hear tuple more often. Totally up to you. So what is it? Well, it's simply an ordered collection or grouping of items. And you might think, well, that sounds exactly like a list. A list is just an ordered collection or grouping of items. But there's a couple key differences. The first is the syntax. So here we're defining a new tuple. Notice we use parentheses rather than those list square brackets. But otherwise, it's the same. It's comma-separated values. We're not limited just to using numbers. Just like lists, we can use other data types inside here. But the key difference, aside from the syntax, is that it is immutable. So what does that mean? It's a fancy way of saying it cannot be changed. So when you define it, it is set that way. You're not going to be able to update a value in the tuple or delete a value from it like you could with a list. So it's an unchanging way of storing ordered data. So let's take a look at an example of that. Immutable can never be changed. So here's an example. We define a new tuple, just the list, or I keep saying list, it's just the 3 values, 1, 2, 3. And we could check, okay, is 3 in X, which by the way, we can use in just like we can with a list, that returns true. But if I try and access the 0th item in the tuple and change it to something, we get an error. Tuple object does not support item assignment. So let's make our first tuple, very simple one, and we'll start. The next slide after this is about why you would actually use these. But let's start with a simple trivial example like the alphabet. So we'll just do alphabet equals and parentheses, and I'll just do A, the string, B, the string, C, and let's go to D. So just comma-separated values, just like a list, except we're using parentheses rather than square brackets. And I hit enter, and if I look at alphabet, you can see it gives us the same thing that we put in. And if I try doing something like type of alphabet, you can see it tells us it's a tuple. And if I tried to add something to it, which if we had a list, we would do something like, alphabet.append E, tells me, there's no attribute append, so it doesn't know about that. So what if I try and update something like the 0th item equals, and I'm going to change it to capital A. Tuple object does not support item assignment. So you can see from here, it is immutable. Once we define it, we have one chance, we set what we want in there, and we don't alter it. So why would you want something like that? Why use a tuple? And there's a couple reasons. The first is that tuples are faster than lists. The whole idea is that they are lighter weight. So if you have an ordered collection of data that you know is not going to change, and we'll talk about some examples in a moment, if you know it's not going to change and you know you don't need some of the common list methods, you can make it a tuple and it will be faster. It can make your code safer, not necessarily safer in a security sense, but safer from bugs and problems popping up because a tuple cannot be changed. You can treat it the same always, all the way through your code. If you have a given tuple, you know it's always going to look the exact same way. It's not suddenly going to be empty or suddenly going to have a new item in there. It's kind of similar to when we talked about dynamic versus static typing early on, how some people argue that a statically typed language is safer and it's easier to write code for because you can always expect a given variable to be the exact same data type it was before. On the flip side of that, though, flexibility is always a good thing, which is why lists exist. A lot of the time, your data does need to change. Okay, so another thing is that we can use tuples as valid keys in a dictionary. So that's just another thing to know about. And you'll also see them in the wild. So we've actually already seen them. I hinted at it briefly when we saw dictionaries in the last section and we did .items on a dictionary. It returned a list of tuples. So let's talk about some examples. A really simple example would be things like the months of the year. So, January, February, March, April, all the way to December, those are always in the same order and they never change. So if we just needed to have an ordered list, or in this case, a tuple of the months, it's easier, it's lighter weight to use a tuple rather than a list. We could easily accomplish the same thing by just, moving that over, changing the brackets. But if we just use parens, it is a tuple. So as far as creating them, we use the parentheses, or just like with dictionary, there's dict. We can use the tuple function. We can access them just like a list. So we actually use the square brackets to access things. Just like with a dictionary, we use the square brackets. So it's really only different when we are creating them. We use parens. When we create a dictionary, we use the curly braces. But then we always use the square brackets to access data out. There is an order, so we can do things like, if I copy this over and I paste it in, we have months. And I can do things like, what is the first month? Month 0 is January. How about months 11, December? Remember, they start at 0, just like with a list or a string. Or we could do, 4 or so on. It's also worth noting we can have duplicate data in there. So we can have multiple 3s. In the case that I just showed you, it didn't make sense for months. There's no rule that your data has to be unique. And other than that, they're pretty straightforward. In the next video, I'll show you there's only a couple of methods that tuples come with. But one thing that I will show right now is how we can use tuples as keys in a dictionary. So imagine we had a website we're a big company and we have, 10 offices across the world. And we want to show them all on a map. You've probably seen something like that before where there's a map with a couple pins on it. And, or like on the Walmart website or Target or something, they show you, find your nearest store. If we wanted to store location data, latitude, longitude, coordinates, along with what they represented, the name of the office or the name of the store or something, here's a simple example of using tuples to accomplish that, using them as keys in a dictionary. So here we have a tuple, latitude, longitude pairs. The order does matter, right? Latitude comes before longitude, I think. Latitude, longitude, yeah. And we use parens, and we're using them as a key. Instead of using something like, a string here, we're using a tuple, and its corresponding value is a string. So if I paste this in here, I could do something like, I'm just going to copy this. Let's go for the San Francisco office. If I had this coordinate somehow, I use the square brackets, and then I pass in the tuple. Oh my gosh, I can't believe I just mixed it up. And we get San Francisco office out. So just to show you, you can use them this way. If we tried to make a dictionary, I'll just do this on a single line with a list. So I'll do a really simple version, 35, 39, and set that equal to Tokyo office. We actually get an error. It says unhashable type list. And that's because you cannot use a list as a key in a dictionary. But you can use a tuple. Why did I just switch to saying tuple? I said tuple all this time. Anyway, so that's important to know. We can use tuples as keys, and we can't use lists. So it's not a matter of, it's faster if you use a tuple. It's a matter of you have to use a tuple if you're trying to use any ordered data as a key. The last thing I'll show you is that some dictionary methods, like .items, will return tuples. So here's a cat dictionary. Name is Biscuit, age is 0.5, favorite toy is my chapstick. She's obsessed with my chapstick. If I paste this in, I look at cat, it's a dictionary. I could do, type of cat is dictionary. But if I do cat.items, remember we get this, where it returns a list, but for each item in there, it's a tuple. And the reason that it's a tuple rather than a list is that this is not going to change. When I get this back, when I run .items each time through, it's just going to give me the current state. So there's no reason for it to make a list because I'm not going to update these values. I might update the actual dictionary, but I'm not going to touch these. I'm usually just going to print them out or send them off to some function, do something with them. So these are tuples. All right, so I'll leave the video off here for now. We saw that tuples are very similar to lists. There's an order. We access data out using the same list brackets, but they're different in that they are immutable. They do not change. We can use them as keys in a dictionary, and also some methods like .items we've already seen will actually return tuples to us. Next, I'm going to show just a couple of quick tuple methods. It will be very fast.